Okay, today we're going to take what we learned in the previous two lessons about exponential growth and decay, and we're actually going to do word problems with them now. The exponential growth formula is a really important one because if you're in my class for the entire lecture, I'm actually going to spend probably 15 minutes of the class talking about exponential growth and why it's so important in the real world. But I'll tell you this right now, just a real quick summary. The reason that rich people stay rich is because of the exponential growth formula. Okay? And if you want more information about that, stop by and see me. But it's a very, very important formula. And I wish you were in class to hear the lesson today because it's actually a very useful one. But the growth formula, remember, was y equals a times 1 plus r to the t. And the decay formula was y equals a times 1 minus r to the t. Right? So in each problem that we do today, we need to solve these as best we can. You can use a calculator to do the hard math, okay? So when you do the crunching, you can use a calculator. All right. So what I need you to do is, on each problem, we're going to have to identify the A number, we're going to have to identify the R number, and the T number. And we're also going to have to identify if it's growth or decay. So let's read this. The population of 422,000 people increases by 12% each year. What is the population after 5 years? All right. It is an exponential growth or decay. Is the population getting bigger or smaller? It increases. That's the key. So it is growth. The first thing you have to do is recognize that it's growth. So once I know that it's growth, I know that it's going to be y equals a times 1 plus r to the t. Okay? A is my initial amount. How much did I start with? How many people did I start with before they started growing? 422,000, right? What's my rate? 12%. But I need to turn that into a decimal, so 0.12. Okay? And then the time, how long is this going on for? For 5 years. 5. Then all I have to do is fill in the blanks. Y equals 422,000 times 1 plus 0.12 to the 5th power. Now, let me help you understand this real quick. Why do I use 1 plus r? Each year, I want you to understand that each year you get all the people that you had before plus 12% more. Does that make sense? You get 12% more than what you had before. Now, what percentage of people did you have before? Well, you had 100% of the people, right? And then you got another 12% of the people. 100% of the people is all the people you started with plus 12% more. And that's why I use 1 plus 0.12. The 1 represents the 100% and the 12% equals the 0.12. So I end up with what? 422,000 times 1.12 to the 5th. Okay? Now what's interesting here is something. The growth rate is 0.12, right? The growth factor is different. There's a growth rate, which is the R number. Okay, that's easy. The growth factor is the number after you add or subtract from the 1. So the growth factor is 1.12. Make sense? Growth rate is the R number. The growth factor is the 1 plus that number. Yeah? All right. So what I need to do now is solve this. And like I said, you can use a calculator to solve this. So I'm going to bust out with the calculator, do the math on a calculator. And I get 422,000 times 1.12 to the 5th power equals that many. I round it to the nearest whole number, so I get 7, 4, lost my calculator, 743708, 743708, 3708. Right? What does that mean? What this means is if I started with 422,000 people and each year the population grows by 12%, in 5 years I will have 743,000 people. Got bigger, right? All right, next problem, example 2. A car bought for $13,000 depreciates. If you don't know what depreciates means, it means it goes down in value at 12% per year. What's the value of the car after 7 years? Well, the first thing you have to do is recognize the price is going down, so that is decay, which means it's y equals a times 1 minus r to the t. So let's fill in the blanks, a, r, and t. How much was the car originally? That's the initial amount. How much was the car originally? $13,000. Depreciates 12%, so the rate is 12%. But remember, what do we have to do to this? We have to turn it into a decimal, 0.12. How many years? 7. Got it? Fill in the blanks. 13,000 times 1 minus 0.12 to the 7th. So this is going to be 13,000 times 0.88 to the 7th. Got it? Plug that into a calculator. 13000 times 0.88 to the 7th power, and we get about 5,312. So after 7 years, the car will be worth 5,000, what did I say, 712? 312. So it's worth about $5,312. Give or take a little bit, yeah? All right, don't forget, I want you to tell me what the decay rate is and the decay factor. The decay rate is the R number, which is 0.12. The decay factor is the 1 minus the 0.12, it's the 0.88. Okay? There you have it. Next problem. Really need you to pay attention here. In this problem, it should say example 3. So fix that, please. In example 3, we need to be careful here because the R number is hidden. It says the initial population of 740 endangered turtles doubles every 5 years. Find the growth rate and the population of the turtles after 15 years. Okay? Oh, find the growth factor, sorry, not growth rate. Find the growth factor and the population of turtles after 15 years. All right, first of all, the turtle population is getting bigger, so it's going to be a growth formula, right? Which is y equals a times 1 plus r to the t. All right. A, R, T. A is initial amount. Okay, I started with 750 turtles. The rate. I'm going to come back to this in a minute, but the time is easy, 15 years, right? All right, so let's talk about doubles. When something doubles, what percent is it getting bigger? It's not 200% bigger. Doubling means it gets 100% bigger. and I spent a lot of time in class talking about this for a while, but when something doubles, it gets 100% bigger each time. So think for example, if something doubles, it starts from 1, then it goes to 2, then it doubles and it goes to 4. How does 1 become 2? By getting 100% bigger. How does 2 become 4? By getting 100% bigger. So when something doubles, the rate is actually 100%. Or if you turn that into a decimal, 1. Not 0.1. All right, fill in the blanks. 750 times 1 plus 1 to the 15th power, which means 750 to the 2. Now, real quick, I made a big mistake right now. And I fell for it just like a lot of you would probably fall for it. Right here, I need you to read this carefully with me. The initial population doubles every 5 years. So question, every 5 years doubling, so how many times is it going to double in 15 years? Every 5 year it doubles, how many times is that going to happen in 15 years? It is not 15 times. It's not going to double 15 times. How many times is it going to double? Well, how many groups of 5 does it take you to get to 15? 3. These should be 3 because it's going to double 3 times. Got it? Be very careful with that. If it's doubling every 5 years and there's 15 years going on, then it's going to double 3 times. Yeah? All right, go ahead and do the math. Bust out old Mr. Calculator. 750 times 8, because 2 to the 3rd is 8. 6,000. There's now 6,000 turtles. Okay? Question? What's the decay rate? Oop, not decay. We're not killing turtles. What's the growth rate? And what's the growth factor? The growth rate is 100%. The growth factor, 100%, which is 1, and the growth factor, which is 2. Got it? All right. Last 2 examples. In your notes, you can knock off this example. We're not going to do that in class. Next problem. And in fact, the rest of these I'm actually not going to do for you. I'm just going to help you set them up. You're going to actually solve them on a calculator later. All right? All right, in this problem, how much of the radioactive kind of radium will be left after 8 days if its half-life is 4 days? And you start with 48 grams of the radium, right? So, first of all, half-life. Let me explain to you what half-life is. All right, if I have, let's say I start with 8 atoms of radium, and every time its half-life means how long does it take for half of it to deteriorate. So it takes 4 days. In 4 days, 4 of those would be gone. And in 4 more days, 2 more would be gone because half of that is gone. And in 4 more days, half of that would be gone. Does that make sense? So a half-life is how long for half of it to disappear. That's something you'll study in chemistry later on. But the half-life is what we're dealing with here. So it's getting smaller, right? So that's decay, which means y equals a times 1 minus r to the t. Initial amount, how much do I start with? 48 grams. The rate, I'm going to come back to. The time is something I have to be careful with. The half-life is 4 days. So in 8 days, how many times is it going to cut in half? Not 8 times. 4 days, 8 days. The time, how many times is it going to split? Twice. Because 8 divided by 4 is 2. All right? Now the rate. If it's cutting in half, right? So let's do something. We start with 4, then it goes to 2, then it goes to 1. How does 4 become 2? What are you multiplying by? Well, 0.5. 0.5. 4 times 0.5 is 2. 2 times 0.5 is 1. So what's the decay rate? 50%, which is 0.5. Plug in what I know. 48 times 1 minus 0.5 to the 2. Remember, why is it to the 2 and not to the 8? Because it deteriorates in half every 4 days, so in 8 days that's going to happen twice, right? So this is what is this going to be? 48 times 0.5 squared. So bust out your calculator, figure out what that is. 48 times 0.5 squared equals 12. What does that mean? Well, after 8 days, there will be 12 grams of this radium left. What's the decay rate? The rate is the number, so it's the 0.5. What's the decay factor? This is kind of cool because the decay factor is that number. The R number is the 0.5. The factor number is the 1 minus number, so it's also 0.5 because half is half, right? 1 minus a half is still a half. Got it? My answer is 12, though. Okay? All right, last example. If you were in my class when I taught this lesson, you would have saw that I spent a ton of time talking about compounded yearly. What this means is, let me read it to you first. You put $350 in a savings account that earns 3% annual interest compounded yearly. You do not make any deposit or withdrawals. How much will your investment be worth in 4 years? So this is a pretty cut and dry one. It's getting bigger, so it's growth. All right? Which means y equals a times 1 plus r to the t. So the initial amount is 350. My rate is 3%. It's a pretty easy one, which is 0.03, not 0.3. And my time is real simple, 4 years. Right? What happens here? This happens in life all the time. You get because you put it in a savings account, the bank is going to borrow your money from you. That's basically what you're doing when you put it in the bank. You're letting the bank borrow your money. And they're going to give you 3% interest on anything that's in your bank account each year. Okay? So you're going to have more money at the end. So watch how much money you'll have. $350 times 1 plus 0.03 to the 4th, which becomes 350 times 1.03 to the 4th. Do that on a calculator, please. Uh, 350 times 1.03 to the 4th equals about 394 people. Okay. Oh, what did I say? 394 people. 394 what? $394. So that means if you put your money in the bank after those 3 years, you'll now have $44 more. All right. Decay rate. I'm sorry, growth rate. Is the 0.03. Growth factor is this number, which is the 1.03. Okay, there you have it. That's how to do exponential growth and decay formulas in the real world. There are a lot of things in the real world that deals with exponential growth and decay. Money in the bank is exponential growth. Chemistry, a lot of times deals with decay. Depreciation of cars deals with decay. Population of endangered animals could potentially be about decay. So as you can see, these are actually very useful in the real world in higher level mathematics. So good luck with that.